First four are all pretty simple. We roll a die, so what I know about my die that I'm going to roll is that it has a side with 1, 2, 3, 4, 5, and 6. Okay, that's what I know about my die. Find the probability of number 1 that I roll a 5. Well, there's a 5 one time, and there are 6 total numbers. Okay, if you put fractions or decimals, that is fraction. If you put decimals or percents, that's okay, but I left mine in fractions, so I'm stopping there. Number 2 says you roll a prime number. Had to know a little bit about prime numbers. Prime numbers is something times it's the only factors are something in itself. There's not anything else. 1 is neither prime nor composite. 1 is special. It doesn't fall into either category. So prime numbers that I have are 2. A lot of people miss that one because it's even. But 2 is only 2 times 1. 2, 3 is prime, and 5 is prime. So I have 3 prime numbers out of 6, which is a 1/2 chance of rolling a prime number. Number 3, a multiple of 2. 2 times 1, 2 times 2, 2 times 3. There's 3 multiples of 2. So that one was 1/2 also. Number 4, a number greater than 6. I did not write any numbers up there that are greater than 6. So number 4 would be a 0 probability. Okay, 5 through 8, you can hit those in your calculator. I'll go through the answers to make sure you got them correct. On number 5, there were only 10 of those combinations. On number 6, the permutations, there was 210. Number 7, there were 70 of those combinations. And on number 8, there were 1,680 permutations there. Okay, everybody good so far? All right, number 9, you're looking to choose a cable company, and there's the table of what they've got. What's important to us, there's the satisfied and not satisfied. So on that table, I just did some little final marks on that. Company 1 had 8 people that were satisfied out of 11. Okay, I just counted up how many were satisfied and how many total there were. Company 2 had 4 satisfied people out of 6. Company 3 had 6 satisfied people out of 10. And then Company 4 had 5 satisfied people out of 7. Okay, then I went and put those 2 percentages, and this Company 1 had 73% satisfied. Company 2 had 67% satisfied. Company 3, that's a 60% satisfied, and Company 4 was a 71% satisfied. So my highest percentage of satisfaction for the company was Company 1. So that's what I would choose as Company 1. They've got the highest percentage of people satisfied. Okay, everybody all right? Okay, number 10, it wants to know, based on that information, if those events are independent or not, and explain. If I took event A, which is 3/14, and I multiplied it by event B, which is 1/5, that would get me 3 out of 70. So that would mean that the probability of A and B would be, if they're independent, would be 3 out of 70. But they told me that the probability is 3 out of 65. So that means it's not the same there. 3 out of 70 is not the same as 3 out of 65. So no, they are not independent. If it were yes, what I got when I multiplied would have been the same as what they told me. Okay, everybody all right on that? See what we were looking for?
Sorry. If it was the same, then it would be independent?
Yep. Yep. All right, and we're not going to have to worry about binomial theorems, so we're going on to 13. On 13, part A says, what's the probability that a dart will hit the circular region? So when you've got these, what they call geometrical probability, you do the area of what you're looking for over the total area. So if it hits the circular region, area of a circle is pi r squared. So it'll be pi, the radius is 12 squared, over the area of the whole thing. That would be 30 squared.
Why would you say area of what you're looking for over what?
The area of the whole thing. So that got me 12 squared is 144. 144 pi. 30 squared is 900. I was looking to see if it told me how to write my answer or not. I actually took this out to a percentage. So when I did 144 times pi and then divided it by 900, I got just, a lot of y'all stopped it at 50, and that's fine because it didn't tell you where to round. But I rounded to about 50.27%.
I got 40 wrong.
Well, you did something wrong. What did you do different than me? What's 144 times pi?
Where did you get the 144?
12 squared.
I did pi times square.
You
I
did.
did pi 12 squared.
What'd you get on that part? Okay, now divide it by 900. You didn't divide it by 900, that's where you went wrong.
I got 0.503 on the sheet.
Well, I don't know, that's wrong for me. Alright, part B, it wants our dart to hit in the square but outside the circle. Okay, so if we've got the circle and we've got the square, we're wanting to hit in this stuff out here. So we got to find the whole square for the part we're looking for on the top, the whole square minus the circle. So that would be 30 squared minus pi times 12 squared on top. And then on bottom, the whole thing is still a 30 squared. Okay, I simplified that a little bit on my paper. I did 900 minus 144 pi over 900. And that got me about 49.73%. Again, a lot of y'all rounded to 50. I saw when y'all were working on it. That's okay. Didn't tell you where to round to. Okay, part C was the one where I saw the most wrong answers. Part C says, in order for you to win the prize, you got to hit the circular region with 3 consecutive darts. What's the probability of that? Well, that goes back to your A answer. I got a 50.27 of hitting it one time. I got to do that 3 times in a row. So I've got my A answer. I'm going to put it back to the decimal. 0.5027 on the first try. 0.5027 on the second try. 0.5027 on the third try, which got me 12.7%. Hey.
So we put 13%.
Yeah, 13 would be where that would round to.
If it was 12.5%, is that terrible or is it close enough?
What did you use to get the, did you just do 0.5?
I did it as like 50%,
Yes, that'd be
and
fine.
I did 1 half times 1 half times 1 half.
Yeah, that's fine. I wish on stuff like that where they used one answer to get another, they gave you some rounding rules so that we would be closer, but since they didn't. Alright, we'll get that ready. We're on to number 15. We marked 14 out because it was more the binomial distribution. So we're on to 15. Alright, 15 on A and B, they gave you 2 completely different types of problems. And the dilemma that I saw all day when y'all were working on it was y'all tried to treat A and B the same, but they're both worded completely as different types of problems. We're using the same deck of cards, but other than that, it's different. It says on part A, you choose one card at random from the shuffled deck. Find the probability that you choose a black card or a jack. So first thing I had to do was add up all the black cards. 2 plus 18 was 26 black cards out of 52. Okay, it said a black card or a jack. Your or, probability of A or B, says probability of A plus probability of B minus probability of A and B. So I'm going to add this to probability of a jack. So I look there, I see I've got 2 reds and 2 blacks, so I've got 4 jacks. Minus the probability of both. So how many black jacks are there? So that would be how that would set up. So 30 minus 28 out of 52, which is 7 out of 13. I left mine that way. If you put it as a percentage, that's okay. They didn't tell you how to do it. Be a little bit more, 50%. Anybody got that? Nobody know what it
I
is?
think I got 54%. Yeah.
You know, 7 out of 14 would be 50, so it's a little bit better than that.
Yeah, it's like 0.538. So
All right, now on part B, completely different question. It says choose card at random, do not replace it, and then choose a second card. Find the probability that you choose a non-face card followed by a queen. So we're looking for probability of a non-face card, so I'm just going to say a regular card because I should have said number card. Non-face card and a queen. When it's and, you're multiplying. Okay, so a non-face card, I add up the non-face cards. I've got 18 black and 18 red, so that's 36 out of 52. And I'm multiplying. What was the other one? A queen. I got 2 black and 2 red, so I got 4 queens. But it said I don't put my first card back. So it's 4 out of 51. Okay, and I multiplied that. I didn't write my first answer down. It ended up reducing down to 12 out of 221, which would be a very small percentage. I don't know what it is. Anybody know?
I think I got 5.
Okay. Alright, so the last A and B on 16. We ready? We've got here 15 students, including you, in your student council activity. Your closest friends are Rachel and Randall. 3 students must be picked by your teacher of the activity. What's the probability that you, Rachel, and Randall are picked by the teacher? Well, if I don't, and when I made the mistake on this one, when me and David were working on Friday, I did B first, and that confused me. But I haven't read B yet, so I'm not worried about that. I just know that me, Rachel, and Randall want to be picked. It doesn't matter if I get picked first and Randall picks second. We just all want to be picked. So the order is not important on this. So I've got 15 people, and I can take 3 combinations. Okay, so what's 15 combinations of 3? It's 455, right? And now what Anna said is 1 over 455, and that's correct. The reason it's 1 over 455 is because I'm only worried about the one combination where me, Randall, and Rachel all got picked. So this is how many arrangements there are. I want the probability is my 1 of us 3 getting picked out of the 455. So you just did the combinations and then you put the 1 over it. Okay, but now when we go to part B, it says the first student chosen is going to be the president, the second the vice president, and the third will be the treasurer. So now it's getting specific about what order it's being chosen in. So that means that it's going to be a permutation. So you got 15 permutations of 3, and how many of those are there?
2,700.
Very good. And I want the one where I'm president, Rachel's vice president, and Randall's treasurer. So I'm 1 out of 2,730. Other way you could have done that, and actually the way I did it, I got a 1 out of 15 of me being president, and then a 1 out of 14 of the next person being vice president, and then a 1 out of 13 of the next person being treasurer. He could have multiplied it that way and got the same answer. I think y'all are more calculator minded and go to the P there both. Anyway.
Come here when you're done.
Something's going on there.
That's the overlap, the ones that are black and
Yes. But surely there's more than one way. That's mine. Oh, this is mine.
All right, any more questions on that? Should be fairly simple, fairly straightforward. Have your notes, have your study guide. Right, make an A. Be good stuff. All righty.